Okay, here we go. Guys, Colton. It's so easy. I'm not even, he wasn't even talking to me. I yelled at him. I have to pay today because, so last year at this point, I had sold my house, but I hadn't bought another one. So I was living with my son and his fiance. It was bad. And now when I go back and listen to those videos, I'm so like it's embarrassing to listen to those videos because I'm so mean. I'm just yelling at everyone. So I have to make a new video because I can't post last year's because it's embarrassing. So thank you for being quiet. We are learning new stuff. I think you will like it. Today's stuff is very easy. But here you've got a piece of paper. In a minute, you're going to write on here, or if you want to write on your little graphic thing, you can. But here's what we're going to talk about. Look, it's a goat. Yay! I don't know if you know this, but apparently there is a thing that people do if you live on farms, and that is to make decorations on your property by using a goat. And the reason it works is because a goat will eat everything in its pathway. So people they'll put their goat in an area and they'll have it eat every bite of grass so it will make designs on your grass, right? And yay. So we're going to start off by talking about if you wanted to start very simple and make a goat circle, what we would have done from the last class is we would have put a little stake right here and we would have attached a rope to our goat and we would have let him go. And what our goat would do, Cole and I have a lot to get through. Okay. I know, but I just need to watch. Is that cool? Your goat is going to go in a big circle. Yay, that's how you make a goat circle. You just literally tie your goat up. You leave him alone for like 5 days. He eats everything. Yay. Today, we're going to ask our goats to make a new shape, right? So here's how they make the new shape. The new shape that we're going to ask our goat to make is what we would call an oval, but we don't call it that in math. In math, we call it an ellipse. And it's an oval, right? And our goat can make it. And I'm going to tell you how our goat makes it. And this is real. If you ever want to do this, someone said they might do this for their project. And I thought that would be awesome. So here's what you do in real life. You decide, Caroline, I don't want to go through it twice. You haven't seen this yet, so you need to watch. You would decide where you want the center of your oval to be. That's what you would do. That's the first thing you would do. And then you would take 2 stakes, not one, you take 2, and you'd put them on either side of the center, same distance away. So say you wanted to go out 5 feet here, you'd put a goat stake right there, and you'd go out 5 feet here and put a goat stake right there. And then here's what you do. It's a little weird. Think about a necklace, and if you have a charm on a necklace, you know how the necklace slides through the charm? You do that same thing with your goat. You give him a collar with a little circle on it. And what you do is you attach the same chain to both stakes. Because here's what happens now. As your goat moves, the chain will kind of slide through the collar. So what will happen now is the chain will be long here and shorter here. And then as your goat starts moving and moving and moving, watch what he can do here. He's going to come over here and the chain now is really long here and really short here. And it turns out if you leave your goat for a week, as he moves around and the chain slides through his collar, what will happen is he will make a perfect oval. That looks terrible. It looks like a potato, but that's what he makes. And that's what we're going to talk about today is how to do ovals, an ellipse, and all of the parts, the center, the goat stakes, all of the parts. So I am now going to show you what it looks like in real life, not the goat version, the real math version. So take a look at this guy real quick. So watch what's going to happen. I'm going to move the little goat around. Let me see if I can get that to move. Hold on a second. I'm going to move the little goat around. So watch what happens. You ready? So here he is. That's a little goat. Watch what happens. Woo! See how he can move around? And he kind of goes, la, 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 la. If my slider would move more, he could go all the way around in the whole oval. So there are going to be new vocabulary words today that you haven't heard before. We're going to obviously talk about a center. We're going to talk about what's called the major axis, which is the long side. We're going to talk about the minor axis, and we're going to talk about the little goat stakes, which in math are called the focus. And that's what we're doing today. So now we're going to go to our note part, and we're going to use this piece, because we're going to graph one, we're going to label its parts, and we're going to roll from there. You guys ready? Okay, so here we go. So the first one that we're doing, la, la, la. Oh, that's not it. Here we go. Are you ready? I am going to write the equation of an ellipse. We're going to talk about all of the parts. And then you're going to learn to write the equation of ellipse yourself. So the first one we're doing, I'm going to just check to see what I did yet. Yeah, okay. That wasn't even English. Write this down, please. Okay. The first thing that's going to happen today is all of our ellipses are going to have a center at 0, 0. Tomorrow, we're going to be moving our ellipses around, and what will happen is, instead of it looking like this, it will look like this. Something squared plus something squared, just like we did with circles, right? Because an ellipse is a round shape like a circle. The x gives you the top part, the y gives you the bottom, which is why we need an x squared and a y squared. But here's the problem. So Zach, when we did these yesterday, we set them equal to a radius. And that radius did not change. The goat went out the same direction. But if you look at this guy, here's a little bit of an issue. The goat can go this far, but when he goes here, it's much shorter. So how can I get a radius? Well, I can't really. So we're going to do something a little bit different. We're going to be putting numbers underneath. And the numbers underneath on this first one we're going to do, we're going to put a 25 here, and we're going to put a 16 here. Now, these always have to equal something. And since they don't equal the radius anymore, I'm going to tell you they equal, I say one goat, but they're not. They equal 1. They equal 1. Now you're thinking, oh my God, that looks terrifying, right? That's got fractions and numbers and that are scary. It's so not scary. So we're ready to start graphing. First thing is, we're going to put our center on. Where do we get the center? From the top part. And in this case, it is 0, 0. So let's throw him on your graph right there. Yay. Tomorrow, are we going to be off center? Yes, we will. But today, not so much. Now, the next thing you got to decide is how far out can our goat go in each direction? And it's going to go out different amounts in each direction because it's not a circle. And here's what's so easy. To know how far out to go on the x-axis, we look at the number underneath x. Well, these would be almost ungraphable if they were 25. That's a stupid number. So does anyone have a guess at what I might do to that 25? Square root it. You got it. I am going to go out 5. 1, 2, 3, 4, 5. And what I do in one direction, because the square root is positive and negative, I'm going to go in the other direction. 1, 2, 3, 4, 5. There you go. You've got a little bit of area of where your goat's going to go. But he's going to also have some area up and down. Can we pretty much guess what that's going to be? 4 and 4. You got it. 1, 2, 3, 4. 1, 2, 3, 4. Now comes the part in the show where I get to enjoy myself. I am going to walk around and laugh at your ovals. Draw it in. Go ahead. Try to make it not look like a line. Or a potato. Okay, that is pretty good. That's it. Oh, okay, that kind of is a little squishy here, but not bad. Not bad. Okay. Yeah, that wins. I'm going to say that wins. Yeah, a little lemony. Sorry, looking a little lemony. But that's okay. Mine looks a little lemony. Potato. Got a little potato vibe going. So that's pretty good. Mine looks like a potato. That's the lemon vibe going for it. Okay. So here I go. Oh dear Jesus. I laugh because mine are so terrible. Oh, see that already. It's not bad. That's as good as I get. Okay, ready for some vocab. So if you notice, you have highlighters on your desk. So the first thing we're going to talk about is a thing called the axes. The first axis is the long one. The thing that I've drawn here is called the major axis. Now here's what's important. It doesn't matter if it's on the Y line or the X line. It's about the bigness of it. So in this case, imagine you have a hamburger bun. You're chopping it the long way. That's the major axis. Does that make sense? When you chop it the shorter way, I don't know if you're going to be able to keep up with this. It is called the minor axis. Right? Now, here's a trick. I might ask you, how long is the major axis on this ellipse? And you'd be tempted to tell me 5. And I would tell you 5 is wrong, Andrew. How long is the major axis? Why? And you're right. 5 and 5. We need both. Not squares, 5 and 5. Minor axis on this one, Zach? What do you think the minor axis is? How long? I was going to say 6, but that would be wrong. So, yay. Okay, so be careful. If they give you the axis length, don't think you just square it. Got to cut it in half, right? Now, the next thing, at the very end of your axis, you have a thing, you have an edge at the very end as far as your goat can go, and those edges have names. And the names at the end of the major axis is called the vertex. That is the edge, right? So in this case, the vertex is at 5, 0 and -5, 0. Now, the other guy, we can't call it a vertex because I'm going to get confused. So like a pilot has a co-pilot who doesn't really do anything, we have a vertex and a co-vertex who also is a second-class citizen. A co-vertex. So in this case, it would be 0, 4 and 0, -4. Is everybody with me? Okay. We got a big finish here, Thomas, and the big finish is this. We are missing the most important part. I have planned this out in my head. I have sketched it out. I need to now go to my yard and make it happen. And what I need to know is where to pound in the stakes so my goat can do what he needs to do. And that is the last piece. And what we call those things, the goat stakes. Don't say this in calculus next year. The goat stakes have a word in math, and it is called a focus. Oh, focus. Let me spell that right. Focus. One focus is called a focus. 2 focuses are called a foci. Okay. Colton, almost done. I got a big finish here. We need to find it. It is not on our formula. We've used up everything in our formula. So guess what? There is a very complicated formula for finding the foci. Are you ready? Here it is. You're going to write this down. A squared minus B squared equals F squared. And if you're like, what the hell are those? Here's what it is. When you have an ellipse, The big number underneath we refer to as a squared. Now, here's what I need you to be careful. I am going to write it like this because sometimes the big number is under the x, but sometimes it's under the y, and that's okay. So when we're talking about this action right here, let me get back to it. We're going to say it could be a or b, doesn't matter. This guy could be a squared or it could be b squared, we don't know, equals 1. So to get our focus, look how easy it is. What it's saying to you is this. Take the big number, 25, minus the little number, told you, really complicated, 16, and that will give you f squared. Look how easy this is. 25 take away 16 is 9. Well, obviously, our goat can't go 9 jumps. It's 3, and it's 3 from the center. So the focus on this one, here's what it would be. Watch what we would do. We'd come up here. He only hops on the long axis, right? If he hops on the short one, sometimes he hops out of our circle. So we start right here, and we go 1, 2, 3, and we put a stake in there at 3, 0, and we go 1, 2, 3. We put a stake in there at -3, 0. And we have now graphed and found all the important parts to our new friend, Mr. Ellipse. Talk to me, Kath.
Are we not
They are already squared. Does that make sense? So they show up when we use them, we have to unsquare them. Okay, and you know why? That gives us our positive and negative. Okay, you guys ready to try one? All on your own? Here we go. Give this one a try. Graph it on your paper. This one, here we go. Graph it on your paper. We're going from having it be hamburger way to hot dog way, and that's okay. Oh, I am going to come around and laugh at your drawings today. Now, this one will be harder. Yeah, kind of a football. Yeah, I feel like skinnier there. Oh, okay, kind of got an egg. No, don't change it. That's as good as it gets. I feel like once you start trying to improve it, it just goes downhill from there. You got one good shot. Yeah, because I haven't done anything with the X's and the Y's. Let's see. Go ahead, down here. Like I'm telling you, someone walked by how much they made out. I just was about my that's because it's hard. It's hard to do. Okay, that was good. That's good. And you go too. I'm sorry. I got the little potato bun. Only because I laugh because I can't do it myself. Like if I could do it, I would not mock you. Here we go. I'm ready to start. 0, 0, up 5. 1, 2, 3, 4, 5. Down 5. 1, 2, 3, 4, 5. I'm going to put the vertices on here right away. 0, 5. 0, -5. 0, 0. 1, 2, 3. 1, 2, 3. 3, 0. -3, 0. Ooh, God. Oh, Lord in heaven. Oh, you know what? I'm going to try something new. I got to try something new. Let's see if I can do this. Oh my God. Oh my God. I think I've got it. No, that's not working. That's not working. That would have been so nice. I got nothing. I'm just going to go fast. Just going to commit. Oh, that's okay. Big finish. Gotta get our foci. 25 take away 9 is 16. Obviously, the goat can't hop out 16. It's too many. So he's going to go up 4 and down 4. How do I know it's up and down, not side to side? Because I go on the major axis. So it is going to be at 0, 4 and 0, -4. I got one more for you to try of the graphies. Are you ready? Now, there's a reason we're doing this next problem, because guess what? Not everything's going to come out nicely, because I just can't come up with I only have so many choices. Otherwise, everything is 9, 25, and 16. So here we go. Give this guy a try. Work all the way to the foci, and then we're going to talk about the foci. I totally heard that. That was funny. 64, I think, goes right to the edge of your thing. That's the good news. Oh, it just went from bad to worse. Kind of has a lemon vibe. Didn't even hit on the other side. I got nothing on that one. 0, 0, vertices 8, 0, -8, 0, co-vertices 5. Oh, nope. 0, 5, 0, -5. Okay, so everyone's watching me real quick, because here's the issue. You're going to try to find those foci, and it's not going to be nice. So we're going to talk about what we're going to do when we do things that aren't nice and graphing. So let's do the math here. 64 take away 25 equals f squared. And I'm going to go ahead and say that is 39 equals f squared. So f, gentlemen, watch this please. F is the square root of 39. Now we need to talk for a hot minute about this. Normally in pre-calc, I say leave it, because often stuff cancels. And I don't want you to use a decimal, because often I got a √2 and a √2 and they're going to cancel. But when we graph, my feeling as a teacher, now different teachers feel different ways, I want it to be a number that's usable. I don't know where the hell square root of 39 goes on a graph, but I do have an idea where the decimal might go. So grab a calculator real quick, throw it in your calculator. You're going to get about 6.2. That's the number I want you to graph, okay? So this goes against my normal rules that say don't get rid of square roots. They might cancel. Here, since we're doing real life stuff, and we really want to we want to measure out 6.2 inches for our goat, we're going to use 6.2. So we're going to say 6.2. Now, if you want to say square root of 39, you can, but I'm going to say 6.2 comma 0 and -6.2 comma 0. How do I graph that? You know what you're going to do? You're going to go to 6 and a little bit more, just a little bit more, and put them on. Is that cool? So just letting you know, I can't make everything work out nicely. Don't panic. That's okay. We have 2 last problems we're going to do. You're turning your paper over. We are going to write the equation now. I've given you the equation. We did the graph. Now we're going to go backwards. Here we go. Oh, look at her. She's a beautiful problem. Are we ready? So here's what I knew, Andrew, before I even start this problem, I know what my answer is going to kind of look like. My answer better look something like this. blank plus blank equals 1. Nice and easy, right? So what I'm going to recommend that we do on these word problem ones, I'm going to do a little sketch. Does it have to be beautiful? It does not. But it helps me know what the hell I'm doing. So I'm going to start like this. Boom, boom. I'm going to put a center right at 0, 0. Is it going to be fancier than that? No, it's not. Here's what it tells me. It says one of my vertices is at -7, 0. Well, if one of them is at -7, 0, where's the other one? 7, 0, sure. Guess what? What's going to go underneath the x squared? Because that was my center, x squared and y squared. That's 0, 0. It's going to go underneath my x squared. 49. Be careful, not 7. Got to square it. So 49. Guess what? You're almost home. You are almost home. How about it gives me my co-vertices? One is going to be at -4. The other one has to be at +4. So what's going to go underneath the y? 16. 16. I have an easier time if I do a little sketch. I don't even care if you draw it in at this point. I don't care. You can make it look like almost, because that's what almost stuff looks like. You can do it like that. It just is going to help me, especially on the next problem. Once I have a graph, I have a good idea what I'm doing. Are we okay? Okay, we're going to jump up our intensity, and if you can get this next one, you are home free. You are home free. So here we go. Big finish here. Okay. First thing I'm going to do is I know what my ending should look like. It should look this equals this. Oh, we got a lot of scary words on this one. We're going to go ahead and sketch this baby. We're going to start off with old 0, 0. Love that for me. Yay. Guess what? If you at least get that part right, you know what? You got a lot of points right there. Yay for you. Now the next one, it says this. It gives us our focus and it gives us a tangent. Remember what a tangent does? It lays right on the edge. So let's draw in what's happening here. We got a little goat focus, a little goat stake right here, and a little goat stake right here. We also have a knife, and the knife is shooting down right here at 8. Look at him shoot right here. That tells me the edge of my ellipse. So if one edge is at 8, my other edge is at -8. So guess what I'm going to do? I'm going to just fake this guy and draw him in really quickly, and then we're going to talk about the fact that we're missing something. Have I lost anybody? That's okay. That's okay. So are you full so the little goat pieces go here on the inside, and then the tangent guy, that tells me one of my edges. An edge. Remember, he doesn't get to go inside my ellipse. He's right on the edge. It's like a fence. Think of it like you're putting it right up against the fence. No, wait, you're right. You're thinking how high up do we go? You're right. We don't know that yet. So let's figure it out. Knowing what we know a squared plus b squared equals f squared. I know I've got the a squared. I know I've got the f squared. I don't have the b squared.
Is it 64 under x?
Yes. 64 is good. So here we go. Let's do this. So I'm going to put this here, 64. Here we go. Big finish. No, because it's the edge. You go to the edge. Now, just what Taylor was saying. Hey, I know my formula, a squared plus b squared. I'm sorry, not plus. A squared minus b squared equals f squared. Guess what? I know my a squared. It is 64. I happen to know my f. It was 6. So what's my f squared? 36. Guess what? This is just some baby math. And guess what? The b squared goes underneath. You're not going to square root anything. Just get b squared by itself. That's all you have to do. So let's do that. Nice and easy. I did it like this. Negative b squared equals -28. I don't want negative b squared. I want Positive b squared. So guess what goes underneath the y? 28. Do I have to square root him? No. It's nice and clean, right? That's as hard as they get tonight. That is it. You guys did great. I'm about to show you what you need to do tonight, and I'm going to check out the yellow assignment like I promised I would. So I'm going to leave that up. I'm going to stop taping. I'll answer any questions. Take a picture of the answer key so you can do them tonight. Bye, friends.